So whenever you hear the word optimization, all right, you have to think of maximum, minimum, gradient is equal to 0. Okay? And you have to think of those steps. Summarize. First, you find the first derivative, the first differentials, or you differentiate for the first time. So whenever you're optimization, bam, think of differentiating for the first time. And why differentiating? Because you want to find the gradient function. Because in the second step, you equate the first derivatives to 0. Because at the maximum or minimum or point of inflection, well, maximum or minimum, and also point of inflection, which of course is not really a max or min, it's just like a saddle point. But at the max and min, the gradient is 0. So that is the why we differentiate it for the first for the first time, okay? Because we know at the max and min, the gradient is 0, okay? So we can equate the first differentials to 0. And then now in the first step, you solve for x. You solve for the x coordinate at that maximum or minimum point. Okay, so you have the x coordinate. Then to get the y coordinate, you just substitute that x coordinate into the original function. Okay, and that will give you the y coordinate. So you have the points. It could be either a max or a min. But now you have to do another step to identify whether it's a max or min. You have to differentiate a second time. That means differentiating the gradient function. You want to see how the gradient is behaving. Okay, and we know that if m prime is the notation for gradient of the gradient. So if m prime is greater than 0, okay, if m prime is greater than 0, it means that the gradient is changing towards the positive. Hence, a minimum is created. Okay, here it is. So it's changing towards the positive. Minimum is created. Okay. Now, if you can just copy this. If the gradient is the rate of change of the gradient, okay, remember m prime is second differentials. If the gradient is changing negatively, that means m prime is less than 0. That's not m, that's m prime. M is the gradient itself, but m prime is how the gradient is changing. So if the gradient is changing is less than 0, that means that the gradient is changing towards the negative. That's an m prime less than 0 means. Hence, a maximum is created. Okay, and here it is visually. Once it was positive, and then it is changing, the gradient that we're talking about, the gradient is changing towards the negative. So a maximum is created. Okay, and this is what to bear in mind when you hear the word optimization. And just for curiosity, we can just, go to Google. Go to Google. Just for curiosity, we go to Google and we just type optimization. Optimization in mathematics. So please add that to your vocabulary, make it second nature to you. Optimization. Once you optimization, I'm sure you're going to see differentiation mentioned somewhere. Mathematical optimization. What is going on? People ask mathematical optimization Wikipedia. Well, let's say what Wikipedia have to say about it. So you have mathematical programming optimization, and then BAM of X optimization maximum minimum. See here you have min and max. So the min and max already appeared. The minimum and the maximum point. Okay. And that's what Wikipedia is saying. And just to specify a little bit, you can just type differentiation. Optimization. Okay. And you have some videos and applying differential calculus in optimization. Okay. And you will get those different literature, but it all boils down to the steps that was in our, okay, in our presentation. Okay, so you have a lot of different literature on it, and well, that's the internet for you. You get a lot of different websites. That's why you have zero in on. We have the first derivative test. So apart from the units, our unit is unit I selected unit 10A. Okay, just to method 1, method 2, you have absolute, extrema, and so forth. Okay, and here you have it, max, min, and so. All right, and it'll be f prime, first derivative test for absolute, extrema, f prime x more than 0, f prime x less than. So you have different literatures on it. Okay, and you have f prime prime, that's the second differential test. Okay, and we know it has d squared y and dx squared, so that's why you have those notation in the presentation that we discussed. Here it is, the different notations: dy dx, y prime, f prime x, all that is m. Second differential, d squared y dx squared, y prime prime, f prime prime, and m prime. So m prime looks like it's my my invention. I've not seen m prime. I've never seen it. I just came up with that. And that's the benefit of discussing what we are doing. All right. So we're moving on to number 6 and 7, product rule and the quotient rule. Okay. But always bear in mind, product rule, quotient rule, we are differentiating, we are finding the rate of change of y with respect to x. All right. That's basically what to do. So once you hear the word differentiation, always bear that in mind. Okay. Always bear that in mind. That's basically what is going on. All right. dy over dx, a difference in y with respect to a difference in x, gradient.